In this lab, we'll be inspecting the Address Resolution Protocol, or ARP. And make sure you have your ARP PCAP open from your Network Traffic Analysis folder before we begin. And for many of you watching this will be the first time likely that you'll be inspecting a PCAP with Wireshark. So we'll take our time with this one, and this is an easy segue into inspecting PCAPs using the ARP protocol. So what is it anyways? Well, the ARP protocol really is a broadcasting request, and it goes out to the entire network. And its intention is to discover a MAC address associated with a specific IP address. So let's look inside of Wireshark how this all happens. Make sure you select the first packet if you haven't already. If you've been clicking around, just select number 1. And notice that the destination column indicates a broadcast packet, and the protocol column indicates ARP is being utilized. This means that we have a packet captured here that is utilizing the ARP protocol. So let's go now into the packet details pane and expand that frame 1 header. This header lets us know the interface that was used, along with any length and size information of the packet itself. So we know its origin point now from the interface and the size, but next we need to figure out where it's going. So let's expand the Ethernet header now, and then expand the destination and source headers so we can see exactly where it's going. Cool. So take a look at this destination broadcast address. We can see that it's FF across the board. This is a special broadcast address that all endpoints on the network register and understand to be a broadcast request from the ARP protocol. And that's a key way that a packet like this can be identified by a protocol analyzer to be noticed and recognized as an ARP packet. And you can imagine, right, that all endpoints receiving this makes it a pretty noisy request on the network. But this is just the structure and nature of how these things operate. Now we need to determine the source address, and we can see over here that it actually has some of it partially decoded, where it says gigabyte. And if you look deeper into it, you can see that the real value of that gigabyte portion is actually 74D435. And so there's a reason that it's actually already been decoded, because that portion is the vendor's unique address. And then the following portion is the individual address for this specific unit of that vendor and this type of technology. So we can actually go and inspect that online. Let's check that out. So let's open up a browser and we'll head over to Google. And there are a lot of tools to do this, but we're going to be looking for one called maclookup.app. So it should be the first result if you search for it. And now we can actually enter in the first couple characters of that MAC address. So we'll enter in 74D4, and it doesn't matter if it's capitals. I'm just doing that because I'm used to it. 35. Cool. Yeah, there it is. There's gigabyte technology. And you see this address, that portion right there, the OUI, that is what we recognize as gigabyte. That's actually the organizationally unique identifier. That's a unique ID specific to gigabyte technology. If that portion of the MAC address exists, then we can safely assume that it's actually registered to gigabyte technology. So let's look at the details tab here to get more information about this. And we can see that the range actually exists from 00000, I think I said enough zeros there, all the way to FFFFFF. And that's the maximum range. And that's a lot of addresses. Actually, more specifically, that's 16.77 million addresses. That's a lot. Cool. So now let's go see the ARP header in action. And that's that final header there in the bottom. Let's just go ahead and expand that and see what's going on in that final header. This final header is more specific about what this packet is and what it's attempting to carry out. So like its executive function. And this ARP header will be unique just to ARP. You won't see this elsewhere. Notice how it bundles some information from the Ethernet header into this one as well, with the actual IP address information this time. And now this target MAC address, this is really ARP in action over here. This address is completely zeroed out because this source right now, this gigabyte source, doesn't know the MAC address for that IP. And it's just shouting on the network. It says, hey, everyone out there on the network, I have this IP address and I have no idea who it is. So whoever is this IP address, please tell me your MAC address. And since all the endpoints get this packet, that IP address at 192.168.1.26 will receive this and say, hey, you know, wait a minute, that's me. I'm actually .26 on this network. So if you want my MAC address, here it is. And that endpoint will send a reply packet back to this source, giving them their MAC address. And that's ARP. This happens pretty often on the network. ARP requests get shot back and forth, and addresses are trying to figure out who owns what MAC address so that they can send information to that destination if they need to in the future. And on the bottom right-hand side now, inside of the packet bytes pane, feel free to click around and you can actually see how these packet bytes represent different components inside of the packet details headers themselves. And if we select that FF range MAC address, we can see where it correlates inside of the packet details pane. It brings us right to it. So if you actually look at the binary data, if you look at that packet byte pane in existence, right, it just says full MAC address, so FF across the board, origin, destination, and that's all it's really looking for. So if you're speaking like a computer, that's how it would actually be interpreted, is here's a broadcast address, I want to know this address, and I'm done. All the other information on the bottom side of the packet details, that's a lot more flavoring added for us as humans to understand a little bit better in English what's actually happening in the packet. But at a binary hex level, it's just a couple lines of characters. It's pretty cool, huh? There's a lot going on under the hood, and we'll dive in even more in the next set of labs.